Okay, so in this problem, we want to find the equation of the line tangent to the graph of y equals negative 3x times x cubed minus 2, all cubed, at the point where x equals 2, or x equals 1. Okay, so we're going to need the derivative to find the slope of that tangent line, and then at the end we'll find the equation of the tangent line. So let's start with the derivative. So y is negative 3x times, and that's the key word, times x cubed minus 2 all cubed. And yes, although we'll need to use the chain rule for x cubed minus 2 all cubed, in the bigger picture, the bigger thing going on is the big product. I would probably kind of group this negative 3x together and think of that as my first factor, and think of x cubed minus 2 all cubed as the second factor. So first we have to use the product rule. Okay, so let's add some parentheses there and there. Let me write. There we go. Okay. So the product rule says that it's the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. Okay, so first factor is negative 3x times the derivative of the second factor. That's going to take a little work to do. So I'm going to write times derivative of x cubed minus 2 all cubed. We'll figure that out in a moment. Plus the second factor times the derivative of the first factor. Well, that derivative is easy. It's just negative 3. So we'll put times negative 3 there. Make sure you have parentheses so that it's times negative 3 and not minus 3. Okay. Okay, so that's applying the product rule. Now we need to find this derivative, which is a function inside of another function. So we're going to use the chain rule for that one. So we get negative 3x times this derivative. So we'll bring the 3 down out front to differentiate the outer function around the inside function, and decrease the power to 2, times the derivative of this inside function is 3x squared. And then this one, we could write it like this, but I'm going to move the minus 3 out to the front. That's this minus 3, and write it as minus 3 times x cubed minus 2 all cubed. Okay, that's the derivative. I'll go ahead and clean it up a little bit because I am going to need to plug in x anyways. So this first term, I've got negative 3 times a 3, so I can combine all those into negative 27. I've also got, oops, so that's the negative 27. Then I've also got an x times x squared. That's going to become x cubed. And then what's left is this x cubed minus 2 all squared. Okay, so that's y prime. Now we want to find the equation of the tangent line to the graph of that at the point where x is 1. So that means we need to find the derivative when x is 1. So let's find y prime of 1. We'll plug 1 in for x everywhere. So negative 27 times 1 cubed times 1 cubed minus 2 all squared minus 3 times 1 cubed minus 2 all cubed. Let's see what that comes to. So it's negative 27 times 1 cubed is 1. Then here 1 cubed minus 2 is negative 1. But negative 1 squared is positive 1. So this is just 1 times 1. So then coming here we have minus 3 times, let's see, 1 cubed is 1, minus 2 is negative 1. Negative 1 all cubed is negative 1. So this is going to become negative 27 plus 3, or negative 24, is y prime of 1. So that's the slope of the tangent line when x is 1. Okay, it's important, so I'm going to put a box around it. Okay, then we also need a point on the line. The only point that we know of on the line is when x is 1, but we don't have the y. We're not given the y. So we need to also find the y value when x is 1. So I'm going to find y of 1 and plug in 1 for x up here to get negative 3 times 1 times 1 cubed minus 2 all cubed. So it comes to negative 3 times 1 cubed is 1, minus 2 is negative 1. Negative 1 cubed is negative 1, so 3. So that means the point 1 comma 3 is my point on the line. So that's my x1 comma y1 that I'm going to use when I plug into the y minus y1 equals the slope times x minus x1. So y minus 3 equals, the slope is negative 24 times x minus x1 right there is 1. And that is a perfectly acceptable answer right there.